In today's video, we're going to walk through the features of ServiceStack's Locode App. We'll look at how you can use it to rapidly generate user-friendly applications from your database, further customize with high-level features, and reuse all your efforts when you need a fully custom user interface. By default, ServiceStack provides multiple built-in web user interfaces that are derived from your API services and their related metadata. The low-code generated user interface takes your AutoQuery CRUD services and provides an easy-to-use system for non-developers to manage data and users, which is highly customizable. AutoQuery CRUD services can be completely generated from your database schema, or for a code-first approach, need only the declared data model and request DTOs to generate fully functional API services. Additional attributes can be added to your data model and request DTOs to further customize the functionality of the API services as well as the related low-code user interface. It supports high-level features like lookup fields, file upload and preview, export to Excel, and others, all driven by your data model and API contract metadata. In the ServiceStack framework, we call these features low-code for short. This is different from low-code development platforms or LCDPs like Radzen or Appian, which lean heavily on visual programming to drive code generation that needs to then be maintained into the future. The trade-off being that they are easier to use by non-developers but are often less extensible or harder to maintain as the visual editing system is updated. ServiceStack takes an alternate approach by focusing on the developer experience and keeping all these features still as code, building on top of our solid message-centric API design. This greatly reduces the code you need to maintain while still being highly customizable in a way .NET developers are productive and already familiar. The design principle being that a lot of your service implementations can be inferred from your data model, API contracts, and attributed metadata while still being able to override just the parts you need. This leaves you with a much smaller code base that is easier to upgrade and maintain over time, rather than splitting responsibilities between a visual editor statically regenerating code that may drift in compatibility with your customizations over time. Let's have a look at an example of these ServiceStack low-code features in action. Let's say we're building a prototype for an existing database where we want to get user feedback quickly. Here we have a blank ServiceStack web application created from a template and the sample Northwind SQLite database file representing our existing database. If we wanted to provide a way for, say, back office staff to manage orders, products, and customers, we could do so with just a few steps with ServiceStack Locode. Use the ServiceStack.NET X tool to mix in AutoQuery and SQLite support. Point to the Northwind SQLite database file in a configured connection string, and configure AutoQuery to use generated services. By generating our API services using AutoQuery straight from the Northwind database means we also have runtime generated request and response DTOs whose metadata drives our low-code app. The generated low-code app is hosted in the same application with easy-to-use forms, filtering, ordering, and custom column selection. Additional features like user management, audit tables, and file upload can then be added and customized. We have a fleshed-out example of this kind of approach with customizations using Northwind, which is available on GitHub, as well as a live hosted demo which we'll put links in the description. Here we can see this example with a series of customizations, and complete configuration is built with less than 120 lines of code. This can be a great approach for prototyping or an internal application that can be built quickly for back office staff to manage data. As more customizations are done, you might get to the point where these generated services need to be more specialized to improve the usability and enforce more complex business requirements. Thankfully, the same low-code UIs and features can also be generated from a code-first approach using database model classes and AutoQuery request DTOs. These classes can then be annotated with attributes to further enhance and improve the UI more easily in a declarative way. Better still, you can even use the ServiceStack.NET X tool to run a command to migrate your generated services into a code-first model without losing your customizations that were being applied on startup. As the number of customizations you need grows, having them declared as plain old C# objects or POCOs will make maintenance a lot easier. We have another sample application to illustrate this code-first approach as well, using the Chinook sample database. If we look through the Chinook sample, we can see the code-first database model classes and extra attributes used to enhance the usability of the low-code UI. For example, looking at the list of tracks in the low-code app, we can see foreign keys like album, media type, and genre ID are showing customized friendly names from the related lookup tables thanks to the use of the ref attribute. We also see the use of client-side formatting helpers like international datetime and currencies. Further still, you can extend the low-code app with your own client-side format methods, like we see here with stylize and the use of the generic format attribute on your data model, which will apply on your low-code app. All AutoQuery endpoints also support filtering, sorting, and column selection in the low-code app by default. Just by clicking on the column you want to filter by, you will have the option to construct your filters. For example, a back-office staff member might be looking for larger invoices, so they could filter out invoices with totals that are less than $10. After that, they might want to also only see the most recent invoices. We can use the invoice date and sort by descending order to see the most recent, which combines with the filter of the total. These sorting and filtering preferences are remembered so users can set up common filtered views that they use all the time and have them remembered for ease of use. If they need to change or remove filters, we can click on the filters on the top menu to manage existing filters and ordering, or by clicking on the Reset Preferences and Filters button to remove them all. These user preferences also include custom column selection. By default, all properties of your data models are listed in the low-code app as columns. Users can change this by using the columns icon at the top left of the table and selecting just the columns they want to see, as well as changing the rows per page. With any of these user preferences, the view can be exported to Excel in CSV format to save to your local machine by clicking the Excel button. This will take into account your filtering and preferences at the time, so you will get the same results you see on the screen exported straight to Excel. Another type of customization you can do to the low-code app is replacing the create or update forms entirely. In the Chinook demo application, we can see this best in the album services. Here we can see a completely custom way users can interact with the create album form. We can still interact with fields and lookup tables the same way as we did before, but with a style fitting of the application. These types of customizations can be done by following a file and components naming convention in your own www root folder. For example, here we can see in the Chinook demo, we have custom.html and custom.js under the modules/low-code directory structure. By default, file names custom.js, custom.html, and custom.css will be loaded at runtime automatically if they exist. You can create your components in the custom.html file, like we can see here for the create album form. Lowcode knows to use the right components specifically for albums since it follows the new prefix with the data model name of albums. If we wanted to create a custom form for tracks, we would call the component new tracks. Scrolling down, we can see the same pattern is recognized for the update form using the edit suffix here in edit albums. Customizations for low-code components are all done in JavaScript, built using the Petite Vue library, but we can also benefit from development time TypeScript tooling using TypeScript definitions. These are available via the ServiceStack UI NPM library and can make using the ServiceStack UI API for low-code customizations have all the great TypeScript autocomplete and static analysis at development time. This means you can even get typed end-to-end usage of your ServiceStack services even when making customizations to your low-code app, thanks to ServiceStack tooling like Add ServiceStack Reference. For example, in the Chinook demo, it also has an overridden welcome page template, which is displayed at the root of the low-code app. Looking at the code for this customization, we can see the statement at the top, import query invoices from DTOs. As we can see in Rider, this enables a great developer experience since all the type information can be used to enhance the static analysis during development. These import statements are stripped before getting to the client since we don't have any compilation steps when developing for low-code customizations. Petite Vue enables fast progressive enhancement, so having the additional TypeScript definition gives us a higher level of safety without the slow and complex compilation step. The full documentation for the ServiceStack UI API for low-code customizations is available at api.locode.dev. Links in the description. As both these samples show, you can get a lot of utility from low-code, especially for managing your data with a good user experience. On some projects, however, there might come a time when a fully custom UI is needed so you can have complete control over the user experience. When clicking on a table name in these samples, the low-code UI is utilizing matching ServiceStack services, which are powered by a feature called AutoQuery. So not only do you get the generated low-code UI, which is providing a lot of utility, they are also backed by ServiceStack's fast and flexible services that benefit from all of the framework's related features. This lets developers focus on the business-specific requirements and the custom user interface while rapidly building solid web services that can be reused everywhere. In the example we will walk through today, we are going to look at a sample application called TalentBlazer, where backend staff manage job details, worker contact information, and the lifecycle of recruitment. Links to the full code and live hosted example are in the description if you want to experiment yourself with the final product. We won't walk through step by step how the Blazor WebAssembly UI was developed, but instead look at how the low-code features are built and applied to have both a generated backend and a custom Blazor UI that utilize the same easy-to-use backend services. If you are, however, interested in a longer tutorial video building something like the TalentBlazer demo step by step, let us know in the comments, GitHub discussions, or Discord. With the talent demo, unlike the Northwind or Chinook examples, we don't have an existing database to start with, so we are defining the schema for our application as well. Using ServiceStack's ORM Lite, we can define database tables using plain old C# objects or POCOs. These POCOs can also be annotated and attributed to control column names, table relationships, indexes, and constraints. We are also using a SQLite in-memory database and recreating our tables every run so we can easily iterate on our schema while we are building our application. This makes it easy to switch to a persistent SQLite file or even another database provider like MS SQL or Postgres in the future with the same code. We are also using a NuGet library called Bogus to populate fake generated data so we can better see and test our low-code user interface. The three main tables of this application are job, contact, and job application. The job table persists data related to an open position that needs to be filled. The contact table has our details of the new potential employee, and the job application represents the contact applying for that specific job position. On job application, we can see we are using attributes like audit increment for our primary key, references for table relationships, as well as reference, which pulls in joined table data when using AutoQuery by default. These classes are also inheriting from a class called AuditBase to enable audit history of our data access through our APIs. Since we are using this code-first approach rather than AutoQuery generated services, defining the table model POCOs doesn't yet provide us with any web service functionality. On startup, ServiceStack scans the assemblies specified in your app host for defined API request DTOs. These DTOs define your API contract, and AutoQuery DTOs take a specified database model type to provide the implementation for our create, read, update, and delete services. Here we are defining a basic query DTO class for the contact table by inheriting off QueryDB for our read and implementing iCreate, iPatch, and iDelete for the create, update, and delete operations respectively. Just like any ServiceStack service DTOs, we are also using the iReturnT interface on the create and patch, as well as the iReturn void for the delete, since we want to specify what these operations will be returning. After these AutoQuery DTOs are declared, we will be able to create, read, update, and delete resources from the contact table. Notice we haven't implemented any custom service logic. AutoQuery infers the behavior for the generated service implementations based on the metadata of the request and response DTO that we have defined, as well as the related table class. Navigating to the /metadata path, we can see our contact services listed as expected. Clicking on Create Contact, we are presented with the ServiceStack API Explorer interface, which is built in by default to ServiceStack version 6 and above. This UI provides lots of metadata about each service, which can be used by developers to integrate with your API. Check out our video on API Explorer here. At the top right of the API Explorer interface, there is a link to View in Locode. Here we can see contact listed on the left-hand menu with the ability to do all of the expected CRUD operation thanks to declaring your AutoQuery DTOs. So now non-developer backend staff can create new contacts by inputting their data. And we can do the same with job and job application as well. When creating the AutoQuery DTOs for job and job application as well, we can control exactly what info these staff will be expected to fill in based on the properties in the request DTO itself. For example, our create job DTO does not have an ID since it's using auto increment in our database. We can validate that the salary range lower and the salary range upper are always above 0, and even use an attribute called input, designed to make it easier to extend the Locode UI interface itself. Here we're specifying an input type of text area for the description to make it easier to input long-form text. As we create additional CRUD services for the other tables, we can group our services using the tag attribute. This makes the services appear in a drop-down menu of the same name, making them easier to find. We can also add high-level features like Audit by using the auto-apply attribute with the associated behavior for the audit operation. This means we will have a separate audit table tracking all of the service API calls that are used, as well as populating audit-related columns like created and modified dates. For another visual change, we can also annotate the backing database table POCO with an icon attribute using an SVG or URI, so we can have clear iconography related to each table of data we are managing in the Locode UI. Let's run our application with all our database tables POCOs created and API request DTOs annotated, and have a look at the Locode UI in action to see how this relates to how we've set up our table classes and request DTOs. We've grouped all our CRUD services under the talent tag and specified a custom SVG icon for each one so they're easy to identify. At the top, we have our app user table, which is also being used on our auth feature plugin to control authentication. This has been included in the TalentBlazer application because we wanted to be able to assign tasks to registered users easily in the UI. Having it declared with an AutoQuery DTO gives us an easy-to-use service for searching for staff by various parameters. We can also see here that app user is read-only since we only have a query endpoint for app user declared. And we are also stripping any sensitive information using the ignore data member attribute. Next is contact, where candidate information has been added, including a profile image, preferred working arrangements, email, phone, etc. This table has all CRUD request DTOs configured, so by using the plus symbol at the top left of the table, we get a form to create a new contact which uses the create contact class. As we can see, our validation rules are enforced related specifically to creating a new contact that are listed on the request properties itself. Since the profile URL is annotated with the upload to attribute, our application is aware that values in this properties are backed by a matching upload location configured in the plugin called Files Upload feature registered in the app host. The plugin supports multiple upload locations that can be used and related to by a matching ID, in this case profiles. These upload locations are configured with a virtual file provider, which can be a straight file system or even an Azure Blob Storage or an AWS S3 bucket. Profiles upload location is also configured with an option called Allow Extensions. In this case, it's specified as web images, restricting the files uploaded to web images only. This allows us to easily preview the image right in the Locode UI in the related column using a helpful format attribute and built-in icon rounded option. There are a lot of these different format methods built into Locode already, but you can also create your own as they match JavaScript functions registered with the Locode app. Each contact is also editable since we have declared an AutoQuery DTO using the iPatch interface. Again, we can limit or extend the properties and rules on the request DTO itself to change the rules and behavior in the Locode UI specific to the edit functionality. The job table is also quite similar. However, we are using a reference attribute to pull in related job applications. This is not only handy in the low-code UI to navigate between jobs and related job applications, but it reduces the number of API calls we need to do in our custom UI as well. Since the job and job application table have a one-to-many relationship, we use the reference attribute here to tell our AutoQuery service to automatically pull related job applications with the jobs in a single request, reducing the need for additional API calls if we build a custom UI. Moving down to the central job application table, we can see a lot of additional data from the related tables. The references attribute, which can be used to annotate a foreign key property and specifying the related type, enriches the create and update request DTOs for the job application automatically since they have properties of the same name. For example, if we go to create a new job application, we automatically get lookup fields for contact ID and job ID. Clicking on one of these fields, we get the ability to sort, filter, customize columns, paging, and select rows just like the main low-code view for the related table. Customizations made to the related table's query DTO are also visible in the lookup view. We can see here by selecting the contact ID lookup, we get a list of contacts including the preview of their profile image, which utilizes the file upload and custom formatting we saw before. The Create Job Application DTO also uses the Upload To attribute for a list of attachments, and since these attachments are more varied, we are storing their details in their own table with a relationship of many attachments to one job application. This means users can upload multiple files for a job application when created, just like a form you would build by hand. Another high-level feature enabled in the Talent demo for low-code is the audit tracking of API events. Going back to job application and the update job application DTO, we can see the use of the auto apply attribute with the behavior.audit modify option. This works in combination with data models that inherit from the audit-based class like the job application. Every time the update job application service is called, the auto apply attribute not only populates and updates the modified date and modified by columns in this table, but it also updates a dedicated audit table. These audit details are then visible in the Locode app if we look at an update form on a service where this feature is configured. After updating a record, we can see at the bottom a button with a count of related audit events to that specific record. Clicking on this button will show entries of audit events where each can be expanded to reveal details like what was called, what data was supplied, and a user ID of who made the change. Again, we still don't have any custom service implementations for the functionality we've seen so far. You could prototype an application like Talent, gather feedback from users to save time on building your custom UI. For example, let's say this prototype using only the services and low-code generated UI was presented to staff who used it and helped you iterate on the rules of the system. After some usage, you get feedback telling you that since they would be spending a lot of time in the UI, they wanted an easier way to visualize the timeline of job applications while progressing and filtering candidates during the recruitment process. This is where you would reach for a custom UI since there was a clear business need for one. The good news is all the services that power the low-code UI are completely reusable and easy to use when building your own. And even better, if you're using Blazor WebAssembly like we are for the TalentBlazer application, you can reuse your AutoQuery request DTOs directly in the custom UI application without any changes. Opening the jobs page in the Talent demo, we need to fetch the list of jobs to present on the UI. This is a function on the client called refreshJob, which uses our query job request DTO with the API async function. We get typed end-to-end services that are easy to use, just like in the low-code UI itself. All the same filtering and querying ability is available like all AutoQuery endpoints, meaning developers get to focus on building the custom UI rather than the plumbing in between. In the TalentBlazer UI, selecting a job and we get to see all the related job applications. This is driven by two AutoQuery API calls, queryJob and queryJobApplication. For queryJob, we are requesting data by specifying the ID, so we know we're going to get exactly one job back. We are also using the same job ID to get all the job applications for that specific job. The rest of the filtering logic is then done on the client, but you can quickly see how we could make all this server-driven by changing what parameters are passed to the different AutoQuery request DTOs to filter as needed. Going ahead and selecting a candidate, we now see more of the custom UI with a timeline of events. Since we don't want staff to manually populate events, but instead let the business logic of our application drive this kind of functionality, we can provide a custom service implementation for create and update of phone screening, interview, and offer. The overriding of these AutoQuery service implementations will be what low-code uses when you create or update these tables as well. That is, if you need custom logic but don't need the custom UI, you can easily stick with the low-code UI, keeping your business logic within your service implementation. The way your custom UI interacts with these custom service implementations is also the same. Just like with all ServiceStack services, your request DTOs are your service contract. The service implementation is not the concern of your client. For example, every time a candidate progresses to the next step, we update the job application, create an event related to the job application, and create or update the table related to the stage of their process. The custom service implementation for phone screening is very few lines of code, but it does exactly what we need for the business requirements. Even though we are creating a phone screening and an event, everything is centered around the job application, and we can use the ORM Lite Save References feature after updating the related job application to make this easier. This will take care of inserting a new phone screening row, adding a new event, and progressing the job application status and saving it all back to the related tables. Our Blazor UI refreshes our data sources and we instantly see the result. We've incorporated notes from the phone screening in the comments section for improved visibility so staff have everything they need on one page. So to recap, the talent sample application is an example of how low-code lets us prototype a system focusing on your data and leveraging an automatically generated UI. You can then enhance the visuals and high-level feature integrations of these endpoints by applying attributes to your AutoQuery request DTOs and database classes with minimal code while still focusing on your backend. With just these well-defined models, you get robust, flexible web services without needing to do the service implementation yourself while still being able to override single service implementations when needed. When it comes time to provide your own custom user interface, those same services are right there ready to go, giving you a rock-solid foundation enabling you to focus on user experience. ServiceStack's low-code UI and related features is growing quickly, so we can provide developers a way to produce API-driven systems that become the foundation of your applications. Check out lowcode.dev for more information and let us know what kind of features you would like to see added. Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, let us know in the comments. If you want to learn more, check out our other videos and join us in the ServiceStack community through our Discord and GitHub discussions. ServiceStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.